Hello dear friends, let's start our the next lesson from the NX computer aided manufacturing. So today we'll see the this exercises and the previous example. In this previous tutorial we have seen the this exercise with the face milling. We removed the 5 millimeter the surface from the top surface of this element with the layer 5 layers. Each one was 1 millimeter, so this overstock was the 5 millimeter, so we removed this one. So it is the called the face milling operation, and we discussed it is the tool pass, the rapid movement step over the cutting operations, and so on. So now if you see the product here, we have the other features like here the pocket, the closed pocket here in the center, and here the open the pocket. So and in this case we will see the how to just to remove this kind of pockets using the floor and wall operation in the in the in the milling operation. So we will see the how to do this kind of operation in this case. For the beginning, as usual, it was defined at overstock and the workpiece and zero workpieces of the workpiece. We defined it in the previous exercise. Here, go to the here the moment here geometric view, and here we defined our the workpiece. Double click to the workpiece, and here display this is the workpiece is selected here. Also the overstock is selected using the here the type of the geometry we did it in the previous exercise. So also we defined our the zero workpiece here. Double click here this one, and it is located in the middle the workpiece of the operation. Here you can move it here to the 5 millimeter just to do it exactly fitting to the old stock here, and press OK. So this is our the 0 point, so it is the defined. Now we can go here the operation program operation. So now we need to define for the beginning tool for this operation. The tool they use it for the pocket milling is the end mill, so flat end mill. So we have to create the flat end mill for this operation for the beginning. To create a tool, go here create tool menu, and here so you can select here the mill. It is the end mill for the flat mill. So to create a tool for the pocket milling, or we can create it from the library here. In the previous lesson, we seen how to create the tool from the library. Now we will see the how to create the tool from the here tool subtype. Select here selected. It's by default selected this tool. So in here you can define the it is the name of the tool. For example, we can write here the mill. Just a moment. Sorry, sorry. Go to the manufacturing again. Go to the create a tool mill, and you can write here the instead of one just and mill and mill, and so let's press OK. Then you can define it is the tool is demonstrated here with a diameter of 30, but for the here we can define we have to define the proper tool with the diameter. Let's make it 10. The diameter of the tool is a 10 here. Let's make change it to 10. So you see the tool is to change the diameter, and also you can define here the other dimensions of the tool, specific dimension. For example, it is the length in this case it's 75 millimeters, and the flute length is the cutting length is the 50. So you can define this cutting length as you want, and not as you want. It depends on the depth of the pocket. Now the depth of this pocket is 18 millimeter, and this one is a 50. So it is the okay in our the cases, but we can decrease it. For example, we can make it sorted, because we say that this depth is enough, that this length is enough to obtain this depth. Since this depth is the 18 millimeter here, and here also the 18 millimeter. So it depends this length, that cutting length, that's the fluid length, depends on the how much is your the pocket depth is this. And here, as usual, you can define it is the material for the tool. By default is the high speed steel, though in this case I will keep it like this, and just press OK. Or you can define here that the shank or the folders of the tool. For example, the shank is defined by the clicking here, so the shank of our tool is created. Then press OK. And in the here, just to the machine tool view, here you see the end mill is created. This one is the end mill is created here, which we created. Now we can define the operation. Just go to the create operation for the pocket, and from the type mill plane, and from the operation subtype select the floor and wall. By default it is the selected. We will use the this operation now for the creating the pocket. And for the location, you can define the location. Let's define the location inside of the program. And the tool, from the tool, you will select here the tool which we created for the pocket filling. Here it is the end mill. So, and here you can define, you in the geometry you will define the workpiece. By the defining this is as a workpiece, the system that automatically that recognize the workpiece and the stock of the project by the automatical, so which we define it in advance. So here you can define the method of the machining, that is the finishing, roughing, the same finishing. So let's define for the beginning, see, so it is as a, for example, the finishing operation. So that without any operation we will finish in the just one operation, and press OK. And you will be directed to the menu toolbars of the floor and wall operation. And here you have to specify the cutting areas for the beginning. So for you have to define the cutting the floor here. So here it is, they say that it is not specified. Just click here, you will specify the cutting area. So you can define the method by the edge boundaries for the faces. So the most useful is by the faces. So the cut area, so floor cut area in this case, this is the floor area. So in order to select this floor area, just right click here, select from the list, and you will select this face, not this face, so this face, but exactly the floor this face, so face extruded this one. So you see the floor is selected here in the list. So you can directly select this face. If you want to make the if you want to make the same operation here, the just add click the add new set, and select this face also, for example, and this also two faces is selected here, and press OK. And here, next step is to define the wall geometry. You see the faces selected, two faces. Next step is to assign the walls. You can specify the walls the manually, or you can define it automatically by the clicking this one. If you selected this one, so walls is created automatically. You see here that you see the blue represents the walls, so respectively to the floor area. So you can define the walls automatically or by manually. Let's define it is the manually by clicking here. In this case, you will define the walls, like for example, right click here, select from the list, and you see these walls, and all the walls you have to just select by yourself. So this is the how to select the walls the manually, but I will cancel it, and it is the better to make these automatic walls to see the generate the walls of the system automatically. It is the more efficient way. So next step is to define. So most important to define the specify the cutting floor and walls to these two areas for the this operation. Next is to define the tool. So tool is all defined. This is the here, and you can define the tool by yourself directly here, but in this not it is not necessary for this case. So and tool exists, let's change it along the Z. So let's close it, and our operation is the finishing operation. So here you can define the region, the floors or the walls. So let's keep it floor, and the cut pattern. In the pocket milling, it is the better to use the, for example, the cut pattern like the follow periphery or follow part. It's the most useful efficient way. Let's see the for the beginning follow the periphery, and the step over the constant, then the maximum distance of the step over is the 50%. And here you have you can change these values, the step overs and so on. So and here the floor and blank distance, since in this case our blank distance is 18, that is the depth of our pocket. Let's make it 18, and the depth per cut is let's make it 2 millimeters. So every 2 millimeter will be the cutted, and we can for the this case generate our toolpath to see the result simulation. See the pocket milling is the generated. We can see the from the this side. You see every this step is the 2 millimeter, and since this distance is the 18, and this steps is the will be the 9. So in the both side, on the both pocket. So this is the how is the pocket milling is obtained. Yeah, so here now we can simulate it, just verify our toolpath, go to the 3 dynamic. We can decrease the speed and just play it. So this is the since the finishing operation. So there is no more any, the material is remained here in this operation. So here say the material is removed, every step is a 2 millimeter. So this is just the first step to do the floor and wall operation. So we can make some changes, for example here the depths, you can change the depths per cut and so on. We can make some here the change the cut pattern. Let's make it follow part, and make it simulation again, generate for the beginning, and here the toolpath in this case, and we discussed the toolpaths later, so we will discuss again here, and simulate this operation. This is the another toolpath set pattern. So uh, with the follow part. So So the final result anyway will be the same, but the cutting part of that's the toolpath. In this case, the follow part. In the first case was the follow the periphery. So most used cut pattern for the pocket milling is that this two one is the most useful one is used. For example, if we make here the roughing operation, so in the roughing operation, so in the here if we go here the cutting parameters. So let's go to cutting parameters, and here we have here the stock values. So in the stock values with the cutting operations, with the roughing operation, for example, we can make here the wall stock. remaining 1 millimeter, and floor stock remaining 1 millimeter, and press OK. It means that let's generate it again. So this is the roughing operation, and here after the machining operation, that 1 millimeter material will be remained in the wall and in the floor, and this is the roughing operation, not the finishing operation. So by your design, you can define the type of the operation like the finishing and the roughing. But the important things that after the roughing operation, you have to do the one more definition operation. So you see here the 1 millimeter material is remained. So 1 millimeter material is similar in the roughing operation. So you have to do the one more operation for the 1 millimeter in the finishing. So we can do this later. We will see that this kind of operations later. Just press OK, and let's change it to the finishing operation again here. And let's define here the cutting parameters. So stock values, and stock values change to the again the 0 0. So there is no more material will be the the remainder in the so no more material will remain. Just press OK. So the same way here we have the feed rates and speed. We can define the feed rates and speed for this kind of operation. For the beginning, we can define the spindle speed, and it depends on the specification of the tool. So tool manufacturer will define the specification that we can define for the pocket milling. Let's define this 1000 RPM, and make it here the calculate to calculate the other parameters that automatically and related to this spindle speed. Press OK. So now in this case, let's define the tool path. Here, go to the here the reply, and you see here the tool path is generated, and here the and go here the option, and here the go to the edit display the option, and here go to the path display, and here we have seen there is several colors for the tool movement. For example, the red movement, the red is represents the rapid movement. Here the let me show from the for the beginning from this side. The red movement is this movement of our tool. It's a rapid movement in the air, so without any touching, without any material removal operation. In the code, it is moving in the G00 code, so a rapid movement. So it's a safe movement, call it. And here the blue is represented approach. Here the you see the approach. It means that here the approach. It means that the tool approaches to the pocket, and here the orange represents engagement. It means that here you see the engagement of the tool with the material, the first engagement. Also here we can see the engagement from this side, this side. So engagement, and the tool will come enter to the material from this side, from the right to the left in this case. And here the most important color is this color, so it is the material removal operation. So here all the operations inside of the pocket is done in the material removal operation, and this is the green is the step over. It means that the tool change, it is the steps from one step to another step, so like layer by layer. So and here the same is the cutting operation. It is the first operation, and it is the cutting operation. And here that this color you see, we can see that this color here is the retract. It is the retracting the tool from material. It is the reverse of the disengagement. So here the tool will engage, here they will be the retracted. The same the color you can see I think there is we cannot see here. So this is the retract. So by the clicking, for example, the color here, for example, blue, you can change the color to the any color you want. For example, to the green, like this one, and press OK. Press OK, and here you cannot see the color, but press OK, and by the generating the new toolpath, you can see that this green line. So here you see this green line. Just a moment. You see that dark green is located here. So like this you can change the any color by yourself. So this is the tool path. Now let's step by step see this kind of tool path in order to see the what is the operation here. Go to the verify, and here the let's make it a display of all the tool paths. So tool path, and here see the in this case let's make it see the all the steps step by step. Okay, see here. So this is the blue. So it is the here the approach. Next step is the, you see there is the orange. It is the engagement. First engagement is the first cutting, and all is the will be the cutting operation step by step. So all is this is the cutting is this uh, color which we discussed. So all is the cutting operation with the same color. Now this is the first layer is almost finished like this. So you see the first layer is to finish it. So next is the step over. So for the beginning it will go to the up rapid movement, and again here the engage it means the approaching with the blue. So approaching, so it is the now is the engaging is the orange. Now is the step over. So next layer was the 1 millimeter. So the same, it's already the start of the cutting operation, the same path. So with the follow the part, so the tool path. So in the same way it will go like this. So in this general, we can say that this blue is the approach, the orange is the engagement, the first engagement. So the first touching of the tool with the material. The red is the rapid movement in the air. So it is the retract. That is the, and it is the same as the retract, but it will go to the upper, more upper, and the tool movement, fast movement. And here that this color represents is the most important is the cutting operation. In general, we can say that this color and this color, the red color and blue color is just the non-cutting operation, and this color is just the cutting, and this color is also a cutting operation. It's the same way, and I will play again here, and you see all the layers will be obtained with the same manner, and after obtaining this first pocket it will go along this red line and a safe movement, and the make the operation here you see the engagement and so on. So all operations you see here, the retracting. So this is the how is the tool path is the operated and analyzed in this case, while the machining the pocket, that's the open pocket and the closed pocket in this case. We can speed up a little bit our the process. So press OK and press OK. So here in the program, let's close this one. And the program, we obtained this floor and wall. And the previous lesson, we have seen the floor, I mean the face milling, this operation. So here is the floor and wall. So in order to generate the code for this floor and wall, and just click this one like this, and go to the post processor, and select from the post processor the desired machine which you have available. Let's just select the mill axis here, 3 axis, and here define it is the measurement unit. In this case, let's select the matrix. So press OK, and just press OK again to generate the G code. So this is the G code is generated for this pocket milling. So here with all the parameters. If you want to generate the G code for the two operation, for example, for the this one and this one, you have to select the this one and control the select the this one. You see the two operation is selected with the demonstration of the two tool passes for the all the operation for the face milling and pocket milling. And you can do this with the same, select the post process, select the desired machine, 3 axes, and the units, and just press OK, 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 press OK, just to generate the G code. This G code that is the that represents all the codes for this operation for the face milling and for the pocket milling. So here that how to generate the G code while with the series operation. So here this operation is obtained. So this is the here face milling and the floor milling, two operations for the this for the this part. So this is all for today. See you on the next lessons of our the next courses. See you later.